All right, first question says reflect A across line y equals x. So as a reminder, because it's been 2 days, whenever you see this y equals x, what do I want you to remember to do with that? You flip it. You are going to flip the numbers. Y equals x. You're going to end up flipping it, and you're going to want your new point to be y comma x. All right? Y equals x, you're making it y comma x. What point is A at right here?
2, 3.
This right here is at 2, 3. Do y'all agree it goes 2 to the x-axis and 3 to the y right there?
Yeah.
So how do I flip 2, 3?
3, 3.
Whoa, that was a bad 3. 3, 2 is my answer. And that's all you had to do for that question. Remember, y equals x is just memorizing. Switch the numbers. Letter B says determine the rule and describe the image. So what am I going to want to do here? What's happening from this one to this one? Do y'all agree this is my first one and this is the second one?
Yeah.
What is it doing? It's translating. How is it moving? And you have to choose the same letter. I'm going to go from A to A prime. Or you could do B to B prime or C to C prime. I'm just choosing A. It's doing what?
Oh, moving.
It's going right. Do you all agree it's going right? Do you also agree that it is going down? So it's going right and down. I took your test yesterday. Remember, your test is next Thursday. And when I was taking it, it's a lot of multiple choice. So when you're doing these descriptions, it can feel like a lot of reading because it's a bunch of descriptions, right? Please make sure you're doing what we're doing right now. We know it's right. We know it's down. Go eliminate the ones that don't have right and down, and then that way you don't have to read everything. Does that make sense? All right, how is this moving right?
7.
Let's see, 1, 2, 3, 4, 5, 6, 7. And it's moving down 1, 2, 3. Oh, oops, I did this backwards. My bad, y'all. Hold on. It should be, correct me next time. It should be right 7, down 3. My bad. All right, now we got to come up with the rule. What does a rule always start with? X, Y. Your rule always is going to have X, Y with a big arrow. And then remember, your X is affected by going which direction? Right or left. So if it's right, what am I going to do to my X? Plus 7. Right is positive. Because if you think about it, as you go to the right, aren't you getting more positive on the numbers? What is down doing? Decreasing. Down is like the y-axis, and it's getting negative. Not 7, sorry. Down how much? 3. And that is my rule. Okay? Last but not least, draw the line of symmetry for the following figures. What does this mean, line of symmetry? Horizontal, vertical. You're drawing a line that cuts it in half where it would be the same on both sides. Can you cut a smiley face in half where it's the same on both sides? Yeah, you can. You can just go, whoop. Do y'all agree it's the same on the left and the right? Yeah. What about a lightning bolt? Can I slant? If I slant it right here in the middle, is it the same on both sides? If I fold it, is it the same? No. What if I slice it straight up and down? Is that the same when you fold it? No. What about like this? Is there any possible way that I can slice this and it would be the same on both sides? No. So this one right here is just none. There is no possible line of symmetry for that. What shape is this?
Oh my God.
Hexagon. It's 6 sides. I always remember 6 sides. 6 has an X. Hex has an X. So it's hexagon. How can I slice this to be the same on both sides?
Vertical and horizontal.
I can do vertical and I can do horizontal. What if I slanted it? If I slanted it, is that going to be the same on both sides?
You do have the color shape.
I even think if I do it in the middle. This one has a bunch of them. If you do it at the corners as well. Yeah, it's a bunch of them. Yep, it's all of them. And then what about this? Does anybody know what this shape is?
That's not a rectangle.
It's not a rectangle. Rectangle would have to be 90 degrees.
I know it. It's like a parallelogram.
It's a parallelogram. If I slice this parallelogram like this, are they the same on both sides?
Could
You
you
could
do it?
cut it.
Could you do it smooth?
If I fold it right there, is it going to fold the exact same?
Yeah.
I want to say so.
So actually, I think every year I usually have to show this because that one's not very slanted parallelogram. Let me show y'all a good slanted parallelogram. So a parallelogram is just like a slanted rectangle, right? So do y'all all agree right here? I have, do y'all all agree right here? I have a little parallelogram. Okay. If I fold this right here, is that the same on both sides?
No.
No. What if I fold this horizontally? Is that the same on both sides? It's kind of hard to see, but where's my little camera? There's a little flap right here. No. What if I fold it diagonally? Is that going to be the same on both sides?
No.
So is a parallelogram, does it have any symmetry? Line of symmetry? No. And a lot of people think it does because it's four sides and a rectangle is two. But a parallelogram has none. All right. If you can do me a favor and pass that up and in, or up to the front of your rows, I'll come by and get that. And then grab the notes that we did. It says click me. I'm clicking. Grab the notes that you walked in and picked up. And fold them like a book, please. Today we're going to be talking all about rotations. What does rotating mean? To turn. So everything that we are going to be doing is going to be turning. On our graph, we are going to be turning. Let's talk about that real quick. Let's go in order before I get ahead of myself. Oh, that's why I was all confused. It looks like that. A rotation means to turn around the center. Some other words for rotation are around. What else?
Could it be face sexy?
Ooh, we're going to get to that in just a second. What would be another word that would be used? What?
Backwards?
So anytime we're talking about turning, I need us to focus a lot on the act of circular motion. So whatever you're talking about needs to somehow involve circularity. I don't know if that's a word, but I just made it a word. So you need to be talking around. Don't you agree? Round is a circle. Don't you agree? And so on your test, one of the questions says it's going in a circular motion. And every year people get it wrong. And I don't know why, because y'all don't read, y'all skip questions, y'all just try to look at the picture and answer. But if you see circular motion, that's turn. So back to what Maya said, what would be a full turnaround in a circle? 360 degrees. In this class, do you know what it means to be clockwise? You need a pencil? Clockwise or counterclockwise? Where's he got you? Do y'all know what that means? Clockwise and counterclockwise? Okay, for those that you don't know, let me see if I can edit. Oh, maybe I don't have. Oh, here it is. Okay. On my watch, it does show. You see how the second hand is going to the right and it's going around. That is the motion of clockwise. The way that a clock turns, that's clockwise. In this class, we are not going to go clockwise. I would like you to box counterclockwise. Why does it keep getting fuzzy? Please box counterclockwise. We are going to be going to the left. Why? Do you remember in 6th grade when you learned this was quadrant 1? Where was quadrant 2? To the left. And then quadrant 3. And then quadrant 4. Do y'all remember that? So in math, we tend to go counterclockwise. Always. So that's kind of how I want you to remember it. We are always going to go to the left. How many turns do you need to go? If I were to turn my paper, how many times would I turn my paper to go back to my original? So here's one. Left one. Left one. When I turn my paper, how many times? 4 turns. So 4 turns equals 360 degrees. And because we're dealing with graphs, everything is going to be, we're going to be using the 4 quadrants, your 4 turns, each edge. So how much degrees would be 1 turn? Yeah. How much would 360 divided by 4? Let's see what that is. 360 divided by 4 is, what did I just do? Is 90 degrees. So when you turn your paper, and doesn't that make sense? If I were to turn this rectangle 1 time, how much am I turning it? 90. Does anybody want to guess how much 2 turns is? 180. And do you agree? Have y'all ever done the cha-cha slide? Well, that one's a little turn to the right, whatever. If I were to turn one, look at me right now in my chair. If I were to turn 180 degrees, what's happening? I'm halfway and my back is to you, right? So if you were to turn this paper 180 degrees, what's happening to your paper? It's upside down. And then last but not least, does anybody want to guess what 3 turns is? 2, close. Do another 90. So 1 turn is 90, 2 turns plus 90, 3 turns plus 90 is 270. You were super close. And then we already said how much is 4 turns? 360. Please write all this down with me. Open up your notes. I believe, is it 4 examples? 4 examples. Really, it says 7, but kind of 4. All right. I'm actually going to fold my paper back just so we have, because we're going to be turning, but we'll use patty paper too. I gave you 2 sheets of patty paper today. The first one is going to be what I want you to use today. Please don't write on it extra. The second one is just going to kind of for you to have in your back pocket in case you need it at all next week. Some of you are going to want to use patty paper. Some of you are just going to turn your paper. I'm going to let you choose which way what method works best for you. All right? You know how you're learning. You know what makes a little bit more sense to you. First things first, it says plot the point P at 2, 5 on the patty paper. This is your pre-image. I'm going to do it on both. So real quick, I'm going to plot 2, 1, 2, 3, 4, 5. Can everybody please plot P at 2, 5? And then with your patty paper, cover it up and do the same thing. I want you to draw your origin real quick. Draw a little T right there so you know where your origin's at. And plot point P. If at any point today I'm going too fast, please ask me to slow down. Next, I need everybody to look up. Look up. What I now want you to do is I now want you to turn this patty paper one time. That is rotating 90 degrees. Please turn your patty paper one time and make sure the origin matches up. Where is my new point P at? Plot that. Negative 5, 2. This is P prime. And it is at negative 5, 2. And that is how we rotate. Now, how can I do this without patty paper? Again, I think a lot of y'all are going to like the patty paper. But instead of rotating patty paper, let's say I didn't have any. Watch. Look up real quick. Just look up. Real quick. Look up. I could take my actual paper and rotate it one time. Where is this point at if this is now the top of the Y, this is an X, and this is an X? Negative 5, 2. Because this would be negative going left. So you can do it either way. You can turn your physical paper or you can use the patty paper. Either works. All right, what's the next thing say? Let's plot O at negative 6, negative 8, way down here. And plot the point O. Negative 6, negative 8. Then get your patty paper. You can do the same one where P is at. You're just now going to plot the letter O on the bottom. And what am I going to do to figure out where the new O is? Turn it left one time, because again it said 90 degrees. Yeah, absolutely. What size lead do you need?
Yeah,
Say that again, I'm sorry. What were y'all saying?
Oh, she was asking why didn't you turn it the other way, but we're going.
You always go counter. You always turn it left every time. Correct. Where is this at now?
Is that 8 negative 6?
It is at 8, negative 6. Yeah, mine is a little wonky, but yes. Nope, I did that at negative 7. So it is going to be 8, negative 6. For a lot of you, the hardest part about this is going to be reading the points. My rule. What do you notice? How did I go from 2, 5 to negative 5, 2? It did switch them. Y and X switched. Do y'all agree Y and X switched right here at negative 6, 8, and 8, negative 6?
Yeah.
What else switched?
The Y became the opposite.
That 5 became a what? That negative 8 became a? So my rule is negative YX. I'm going to be honest. I don't remember how we've been kind of memorizing the rules for reflection and everything else? I don't memorize these rules. I turn my paper. Or I use patty paper. The rules get a little bit crazy for rotations.
Always work if you just read off of
Correct. So like if I were to give you an example right here, if I were to tell you rotate 5, negative 6, 90 degrees. Positive 6, 5. Switch them and make that change the sign. You always change that. Yep. Does that make sense? So it'll work if you memorize the rule. It'll work if you have the notes. But if you don't memorize it, just turn your paper. Mm-hmm. All right, write that down if you don't have that down, please. Now, So again, I'm just going to reiterate right here. 90 degrees is how many turns?
1 or 2?
No.
Oh.
It's one turn and you're going counterclockwise, so you turn your paper left. 90 degrees is one turn left. Next one, it says plot point A at 3, 4. Can everybody please plot A at 3, 4? You can use the same part of your thing, but I'm actually going to move it so I don't have too many points. So I'm going to do a different corner of the patty paper. Just don't forget to draw your X and Y axis so you know how to. Plot point A, please. Still going to go left, but this time what is the question asking for? 180. So what am I going to do? How many turns am I going to do for 180? So I'm going to turn my patty paper one time, turn my patty paper 2 times. What happens to that letter A? It's upside down. And where does it end up? -3, -4. That's A prime. A prime's at -3, -4. Y'all think you already know the rule?
Yeah.
What's the rule going to be for flipping 180?
Y, negative y, and positive.
No, look at them. 3, 4 turned into
It's going to be negative x or negative y, negative x. Or, no, it would be negative x.
-x, -y. You just change the signs for both of them. What do you think, and we don't even need, I'm not going to use patty paper for this one. What do you think the point X is going to be if you rotate 180 degrees?
7, -5.
Just change the signs. 7, -5. So if I were to plot -7, positive 1, 2, 3, 4, 5. And if you don't like that, if you don't like this rule, I do like this rule, but if you don't like this rule, take it and turn your paper twice. Turn your patty paper twice. So I have this. Here, I'm going to turn my paper 1 time, 2 times. Where do I end up at?
8.
Close. 7.
Oh.
7, -5. Isn't that what we got? Yeah. So it works. So the rule for 180 is -x, -y. So what if I had, let's do an example right here. What if I told you to rotate 3, -2, 180 degrees? It would be -3 and +2. You just change the signs. We like 180 degrees. And as a reminder, 180 degrees equals how many turns? 2 turns. I want you to notice. Look up real quick. Do you notice how I started in A and ended up over here, or started right here in quadrant 1 and ended up over here? That's because the first turn gives me right here, and then my second turn will give me there. For X, if I'm turning it twice, my first turn is going to bring me down. My second one's going to bring me right. Right. For 90 degrees, how many turns is that? That's why that went over there. Oh, one turn is just right over there. So, what's going to happen with the next one? Can I change this? Are we okay?
Yes.
Which one who said hold on? Okay. Good? Okay. The next one is how many degrees? 270 degrees. And at 270 degrees, how many turns am I going to take? 3. So let's do what it says here. Let's plot U at 5. 1, 2, 3. Can everybody plot U at 5, -4? Again, to me, plotting is the most annoying part about all this. I think on your test for most of them, I'll give you the point plotted. Okay, I'm going to do a new corner. You can do the same one you've been doing. It doesn't matter. Or you can do a new one. I just don't like too many points on it. How many times am I going to turn this patty paper? So I'm going to turn it. 1, 2, the U's upside down, now 3. Where should I end up if I'm going 3 turns? 1, 2, 3. I should end up over here, which is right. Where are we at? -4, -5 is my new U prime. This went up, this went this way, and then it went down. That is 3 turns. I want you to do number 6. Go. -29 is way up there. And then turn it 3 times. 1, 2, 3. Where does F end up at?
-9 and -3.
Be careful. Do it 3 times. 3 times. Here, watch. You did it right here. Did you plot your point right here?
Yeah.
It's the right spot? Okay, so from there, I'm going to go turn it 1, 2, 3. Where do I end up at?
All next year.
Does that make sense? +9, +2. Anybody notice the rule or figure out the rule? Y -X. You still switch them, but now the X changes the sign. Again, am I going to expect you to memorize this rule? No, just turn your paper 3 times. So an example of this one would be if I had 5, 6. How would I change this? 6, -5. And 3 turns equals, or 270 equals 3 turns. Write that part down, please. 270 equals 3 turns. Where is my whiteout? I'm going to need that. Oh, here it is. 270 is 3 turns. And then obviously 4 turns is what? 360. And we're not going to really ask a lot of questions about 360 because it would just be it's the same point. All right. Last question on here. It tells you the pre-image and the image. How many turns did this take? Got the paper. I'm here and I ended up here. Let's do the turns. Physically write the arrows. This is 1. This is, and then this is 3 turns. 3 turns is how many degrees? So, how many degrees of rotation did this arrow have? 270 degrees. And that's the question you're going to have on your test as well. Does that make sense? All right. Are we feeling okay about rotations? They're a little wonky, but that's how they go. I would like you to add this to page 38. Add it to page 38. We're going to call this rotations. And everybody should have glue at their table. Rotations. Did it work? Did that glue work? Okay. Yeah. Yeah, we're counting on it down. How do you go from the number 2 to 7? How much would you add? And then, so you would add 5. So if you're adding 5, is that left or right? So you just write left side. And then you do the next one, the same thing. How do you get from those next 2? I didn't give them that. All right, you are not doing this whole worksheet. On this worksheet, I want you to do the evens. Write that down at the top. I want you to do the evens. You only have to do the evens. What are evens? 2, 4, 6, 8, 10. Does it go? No. 2, 4, 6, 8, 10. That is all you have to do is evens. Did I get everybody's warm up? I think I. Y'all are already in season or not yet?
Tryouts.
This week? Today?
Today,
Oh my God,
tomorrow,
it's so
and
cold.
Monday.
So cold.
And they're not even making cuts. There's like literally no point.
Question, how do we know which one starts